So problem 1, we're going to start, if we take a look, we've got a single trig function, so we don't have to worry about using a property or changing the argument, we just need to get it isolated. And so on this one, I'm noticing that everything is negative, and really the one that matters is the one in front of the trig function. So I'm going to start by just multiplying everything by -1 to change every sign. Okay, if there's ever a point during the video that you feel like I'm going too fast, remember that you can always pause and rewind. Okay, so now we've multiplied everything by -1, and we can now just subtract 3 from both sides. All right, so from here we're going to find our principal value. Remember, ignore the 2x for right now. That'll come into play later. So right now we're just saying, what is the angle whose sine is -0.289? So go ahead and put that into your calculator. Make sure, using the domain up here, make sure that you are in radian mode. All right, so we have our principal value. Don't forget to store that. And then we can start writing our general solution equations. Now, this is a sine function, so your two equations are going to be your principal value plus 2 pi n and pi minus your principal value plus 2 pi n. Now, remember that we still have this 2x floating around, so we need to account for that, so make sure that you're writing that in with your two equations. Okay, so then before we actually write our official equations, we need to, on both of these, divide both sides by 2. Now when you're dividing by 2, don't forget to divide the 2 pi n by 2 as well. It's super important to wait for this step. Don't do it at your principal value. Otherwise, you're not going to get all of the correct solutions. So once you divide by 2, I would restore. So notice I've written down the letters that I've used. So I'm going to store this new one as A. I usually store the first one as X, but the new value, the -0.15, I'm going to store that in as something else. And I like to write it down so that I know exactly what I'm working with. So on the next one, I'm going to do pi minus the stored original value, X. Then I'm going to divide it by 2. So make sure that you're getting the same thing as I do. If not, go back and double check it. Okay, so make sure you have the same general solution equations. Now we're looking for values between -pi and +pi. So I'm going to start when n is 0. And so then I need to have a reminder of where I need to stop. Remember, pi is just approximately 3.14. So we're looking between -3.14 and +3.14. So both of these are okay. So then on the top equation, I'm going to start with that stored value, A. Hopefully you stored the second one as well. So I'm going to start with that value, and I'm going to add pi. I'm going to use the pi button. Don't plug in 3.14. Okay, that's going to be 3. That's less than 3.14. If I add another pi, I'm adding another 3, approximately 3.14. And so then my value is going to be too big, right? It's going to be 6.14. So instead, I'm going to go back to my A value that's stored in here, and I'm going to subtract pi. That one was too small, okay, because I'm subtracting 3.14 off of a negative value already. It's going to get more negative. All right, so then the next one, if I add pi to a positive number, it's going to get bigger than pi, so that one won't work. But if I subtract pi, it will work. Okay, so we're going to take that second stored value and subtract pi, and that's our second particular solution. So you can always verify against your graph. We've got 1, 2, 3, 4 intersection points, so that's exactly what we wanted. So we know we're on the right track. Now we have to write our points as ordered pairs. So remember, look back at the original equation. We want the easier side to work with. Because it's a constant, this is our easier side. No matter what, all of our y values are going to be -2.711. So we'll just write these as ordered pairs. And then name them. Just use different letters for each one. And then go ahead and plot them on the graph. So you're really looking at, does this make sense? We have something just under 0 in the x direction. Yep, right there. We've got 3, that's the biggest value in the list, and you can use the scale if you want. This is pi over 3. There are 3 of those. So then that looks like this is going to be pi, right? So we should be really close to pi. 3.00 is just under that. So that one makes sense, right? And so on and so forth. Okay, again, pause the video, rewind if you need to go back. So now let's try another. Okay, if we look at problem 2, now we've got a situation where our arguments are different. We've got cosine 4 theta and sine 2 theta. Those arguments don't match. That's the first thing to look at before we worry about the fact that we've got cosine and sine. Now, just because we have 2 theta and 4 theta, we don't have to go all the way down to plain old theta. We can keep 2 theta in there. So I'm going to keep this one as is, and I'm just going to use my double argument property for cosine on the first one. So remember, cosine 4 theta means cosine of 2 times 2 theta. Okay, and so what we can do from there is we can use our property. Since we have sine over here, choose carefully. I don't want to have both cosine and sine in here. I want just sine. So choose the version of the double argument property that's going to be the most effective. Okay, so now that we've got all sine and we have our same argument, now it's time to factor. But it's going to be really hard to factor if we have a negative for our leading coefficient, because this 2 is really our leading coefficient. So I'm just going to multiply everything by -1. Both sides, we're multiplying 0 by -1. So that's fine. Totally legal mathematically. So now we've got everything. I rewrote it in descending order. I changed every sign. Now it's time to factor. So go ahead and factor this. Pause the video. Okay, so we've got our factors. And so then from here, we're going to say sine of 2 theta is 1/2 and sine of 2 theta is -1. You can find your principal values. Again, you're ignoring the 2 theta. You're just saying, what's the angle whose sine is 1/2? All right, well, that's 30 degrees. So notice that we're in degrees rather than radians from the domain given. And so that's why we're looking for our principal values in degrees. Okay, so then we're looking for what is the angle whose sine is -1. All right, that's going to be -90. So now we can write our general solution equations. Remember, this is where the 2 theta comes in. So we're going to start off with, we're going to write 2 theta is 30 plus 360n. Okay, not 2 pi because we're in degree mode, so you have to be really careful here. And then this is sine, so it's going to be, instead of pi minus 30, it's 180 minus 30. So that's where the 150 comes in from those general solution equations on the pink sheet. Okay, so then go ahead and try to write the next 2 before you unpause the video and see what I've written. Test yourself. Okay, so you should have -90 plus 360n and 270 plus 360n. If you got 90 here, that means that you're saying 180 minus 90, and you're forgetting that you're subtracting the negative, so be very careful. So now what we need to do is divide everything by 2, including our 360. So go ahead and write those down. Pause the video, write those down, and then unpause so you can check your work. Okay, now that we have our 4 general solution equations, we're looking for our particular solutions. So this time, let's double check and see how many we're going to need before we even begin. So we've got 1, 2, 3 points of intersection on our graph going from -90 to +90. Okay, so let's start when n is 0. When n is 0, we're just taking these values right here. Okay, we're looking between -90 and +90. We don't need any kind of extra steps there. We can just see that all of these work. 135 was too big. So then if we're going to look at an n value of +1, well, we're adding 180 to these 2 positive numbers. Those are going to be too big. So let's double check. If we add 180 to -45, first think, will that work? Nope, too big. And certainly if we're starting at 135, that's already too big, we're not going to have that value. So what we need next is to look at negative values. We can immediately rule out the third equation. And you can take a look at 15 degrees. If you subtract 180, that's definitely too small. Same thing with 75, but 135, we're going to get a value in there. What do you know? It's the same as our -45. And that's because they're exactly 180 degrees away from each other, so we're going to get those same values. If you recognize that ahead of time, you still need the general solution equation, but you didn't have to look for it. Okay, so now we just need to write our equations, or our particular solutions, as ordered pairs. And we don't need to duplicate the -45, that's this point A. So what we need to think about is what's our y value for all of these. So we'll go back here, and we want the easier side. don't forget that 0 is an actual value. A lot of people will plug in on something with 0. We just know, okay, why is it going to be 0 for everything? Super easy, right? So just write your ordered pairs. Okay, so now that you have your ordered pairs written, name them, and then make sure that you're labeling them on your graph accordingly.